I'm Raymond Asensio for Asia Today. When E. coli headlines appear, that usually means bad news of product recalls and a lot of people getting pretty sick. But today, you can breathe a sigh of relief. That is because South Korean scientists have made a breakthrough with the bacterium, saying that they can now make gasoline when E. coli is mixed with organic waste. Now, Lee Sang-yup joins me from South Korea. He's a professor at the Korea Advanced Institute of Science and Technology. He and his team made this discovery. Their work published today in Nature. So congratulations, first of all, sir.
Thank you.
All right, so the big question is, are we going to be running our cars on bacteria and E. coli in the very near future?
Well, probably in the future, but not now. So in this particular demonstration, we were able to re-engineer E. coli metabolism so that the bacterium can produce gasoline out of glucose or sucrose or whatever carbon source we feed it.
Right. Now, how long have you been working on this?
We have worked on this topic with one PhD student for 5 years.
Wow. All right. So you can definitely be smiling today after your work gets published worldwide. Using E. coli, though, why use this bacterium as opposed to other things? You know, when we talk about E. coli, you sort of think of bad news.
Right. E. coli is the flagship organism many biochemical engineers have been utilizing because it is relatively easier to manipulate genetically. So that's thanks to the accumulation of much knowledge around this bacterium. And
right.
Thus, it is not restricted to E. coli, actually. And we are exploring other microorganisms, hoping that better production of gasoline will be possible.
Right. Now, can you break it down for all of us on how it actually works? Now, keep in mind that we're not chemical or biomolecular engineers like you, but just keep it simple and to just walk us through a little bit of a process here.
Right. So bacteria also need something to eat first. And that in that particular case, it is glucose we used. Mm-hmm. And then cells will take up glucose we feed, and then they will produce fatty acids. And now the reason they make fatty acids is to synthesize cellular membrane. However, the carbon lengths of fatty acids used for cell membranes are rather long. And if you convert it to alkane, it will be more like diesel rather than gasoline. So what we did first was breaking down the fatty acid metabolism and engineer it so that cells can now synthesize short chain length fatty acid first. And then we introduced the synthetic metabolic pathways so that it can be converted to gasoline components.
Right, and I understand that this gasoline that comes out is it identical to the gasoline that we already pump into cars?
So as you might know, gasoline is a mixture rather than a single component chemical. And just like that, the alkane mixture we are producing using E. coli is similar to the components contained in the gasoline.
Right. Okay, and I understand it's not a very efficient process right now. It's just, what, a few drops or so, right?
Absolutely. So it is a proof of concept demonstration that actually cells can be metabolically engineered to produce gasoline, but the efficiency and yield needs to be significantly improved if it can be realistic.
All right. So any forecasts on when I might be able to power my car with E. coli?
Unfortunately, scientists do not say that because we never know when the breakthrough improvement will be made. It can be tomorrow or 100 years from now.
All right, that's a little bit of a long time to wait, but with you guys at the forefront, we might get there a little bit quicker. Thank you very much, Professor Lee Sang-yup at the Korea Advanced Institute of Science and Technology. For more on this, head to thewallstreetjournal.com and read the article by our Seoul reporter, In Soo Nam. I'm Raymond Asensio for Asia Today. Thanks for clicking.